meeting is being recorded. Okay. Can you see my screen okay?
Yes, perfectly, Moran. Yeah.
Okay, good. Okay, so here again, we are, wow, we already have 26 people in the room. I'm very happy and excited to see so many people interested in metadata and metadata for research software. And so I am going to welcome you to this webinar, which is more of a working session webinar called Developing Guidelines for Metadata Collection and Curation for Research Software. And as I like to call it, the RSMD guidelines, because we do need another acronym. And so my name is Moran Greenpeter. I work for Software Heritage based in INRIA, France. I am a software engineer and a metadata specialist. I have other hats coordinating the effort on the European project, on the Fair Impact European project, and on FairCo for EOSC. And today we are going to work on guidelines developed in Fair Impact. But before doing so, first, I would like to thank the organizing committee that helped produce this webinar and produce this, deliverable. So first, for the version 1 of this document, the task 4.3 with the listed contributors on this slide. And to thank also Trust IT and Sarah and Rita that are behind the scenes making this webinar possible. And so a bit of housekeeping before jumping into the RSMD guidelines. We are going to work on a document. Here you have the two short URLs, one a bit more semantic and one very, very short, so you can copy it. Be aware that this session is being recorded and made publicly available, and you can add yourself on the participant list in the document itself. So if you want to be listed as a contributor, you can add in the correct column that you wish to be a contributor to the guidelines. And so we will continue with the agenda today. We have a full agenda, very, very full, and a lot of things to cover in an hour and a lot of work to do. And I would like to thank you for taking this time and joining me in being here and working on this and discovering the research software in the Fair Impact project, and then also participating in this large community effort to prepare the guidelines. Then today I will share with you this proposal, which you can already see in the live notes of the webinar. This is not the deliverable, but this will be the part of the deliverable. I will show you later on how the deliverable is structured. And last but not least, we will see how to contribute after this webinar, so you can continue contributing if you wish to do so. And so our main goal is to review and discuss these RSMD guidelines, research software metadata guidelines. And so first, a few contextual items about Fair Impact, the project, the European project in a nutshell. Very large project with 6 major partners here on this slide, but these are the core partners, but a very large consortium. I'm even not sure that this is the full consortium. To let you know who is working on task 4.3, you can see on the slide the partners that have contributed and are behind this research software metadata guidelines, including INRIA, DSSI, and UPM, DataCite, Uniman, and UKRI. Next is about Fair Impact. So again, a bit of context. Fair Impact objective is expanding fair solutions across EOSC, and we are part of core package 4 dedicated to metadata and ontologies. software in Fair Impact is also present in Work Package 3, where we will work on persistent identifiers, and in Work Package 5 with the metrics for research software. So in this project, there's a lot of attention to research software and creating guidelines and practices and policies, identifying practices for also research software. And we will see that the RSMD guide has a timeline, a very short timeline, because the project, the Fair Impact project, has launched only a year ago, and we need to deliver this deliverable at the end of June to the European Commission. We had a very nice workshop co-located with RDAP 20 in March 2023, and the community, and maybe some of you have joined us on this day to contribute to a first activity where we collected metadata use cases and analyzed some metadata. This is also part of the deliverable. And today we have this next step where we get your feedback. We need you to give us this feedback on the live note so that the guidelines that we provide are a really large community effort. Also, I've noted on this slide the FAIRCO for EOSC effort in CodeMeta. So if you don't know CodeMeta, we will come to that later, but the effort was to organize the governance of CodeMeta and contribute to it. And we are on the way to release a V3, and in September, organizing a webinar about CodeMeta. And so clarifying the magic, what is software? This is important before starting to discuss guidelines. We need to agree on what is software. And some of the users see the software as magic, and we need to clarify this magic. And you can find two types of, well, it's not types of software, it's just types of ideas about software. So you have the software as a concept, which is not a digital artifact, and you have the software artifacts. We need metadata on both. We need metadata about the project, about the ideas, about the community, and we need metadata about the artifacts to identify and reference these specific artifacts, also to make them executable. Research software is a subset of software, right? And now there is a definition from the FAIR for research software output where we separate research software from software in research, where research software is created during the research process or for a research purpose. And software in research is used for research. So you can see that many researchers use software, but this software might not be research software. It wasn't created for software purposes. And we really want to focus the research software that was created during the research cycle, alongside articles and data, making this open science ecosystem complete between software, publications, and data. Now, software has multiple facets. It can be a tool that is used. It can also be a research outcome and result. It can be the object of research when analyzing software source code or software, different types of software where researchers take this as an object of research. And the funny thing is that one piece of software can be all three. It can be the tool, but it can be also the research outcome and the object of research. So we need to keep this in mind when providing guidelines. Now, we are here for many things. I am here to develop the guidelines, but there are many stakeholders that have something to do with research software and need metadata for. So we have on this slide a few examples. It is not all of the stakeholders. And why we are providing these stakeholders is that the research software metadata guidelines audience is the end user, which we see as the researchers, the software engineers, the developers, the curators that curate the software, and behind them there are the research organization and the laboratories, but is mainly for the end users. And so the relevant objective is to make metadata for software, for research software, normative. We want people to use software. We want people to use the metadata concepts to describe software. And so here, these RSMD guidance come to help communities to make it more normative, to use metadata and to create metadata for research software. And on this pyramid, you see this is the Brian Nosek pyramid. It is right in the middle. Now, I'm not sharing other efforts where policies are developed or infrastructures are developed, but there are many initiatives around. And today we will focus this work, and this work is for the community. It is not to make it required as a policy, but really guidelines to help communities, institutions to do better with their research software metadata. Now we are getting to the heart of the subject, which is the document, the proposal, the research software metadata guidelines. Again, the new acronym that we really needed, which is RSMD. And so for this deliverable, we will see on the document that you are on. I hope you are on, but if you are not, you should be on. I don't have the link on the slide, but it is shared in the chat very often. So you can just click and go to the document. You will see that you don't see what I have on a slide. You won't see an introduction, you won't see a state of the art, but you will see the RSMD guidance proposal, which we'll walk through in the next few slides. The full deliverable will be shared, for at least the first draft, the version 1, which is still has some work to be done on that. But in this full document, you find an introduction, you find use cases, overview and collection in the appendix. You find a state of the art with existing practices and guidelines, with a metadata analysis of the landscape of metadata and curation workflow. I'm giving you this information so you will stay with me until the end of this webinar, but I will share the link at the end so you can have the full overview. But I wanted us to focus the proposal because this is the important piece that will be given to the end users, the researchers, the engineers, and the curators. So this is what we will review in these webinars, And next, after this the proposal in the document, we have some limitation and challenges, but also few collected recommendations that we found for infrastructures and other stakeholders that are not the end users. Why are we here? What is driving this FAIR impact project about research software? There was the FAIR for Research Software Principles, which were published in 2021. Now, in this image, you can see that the FAIR for Research Software is on this middle box. It doesn't get until the last box, which is the desirable box, where we have fair software, we have it open source, we have it reproducible, we have it robust, quality, everything is perfect on the last box. But for fair, it's a bit limited to what we can do with software. And we wanted to push this limitation with the current RSMD guidelines. With that, we have the EOSC SIRS report, also published in 2020, which is very, it's dedicated to infrastructure, to scholarly infrastructure and recommendation for the infrastructure. So if you remember the pyramid, it's for making it possible. Now the FAIR Call for EOSC project is trying to turn the SIRS reports into a reality with different connectors and APIs from these infrastructure aggregators, publishers, scholarly repositories into the Universal Software Archive. You will see that in other webinars that we will make available for you, and not today. We use this report because there are 4 pillars that are identified in this report, which is archive, reference, describe, and credit, which is cite also. In these 4 pillars, different recommendations are made for infrastructure. We will be used these pillars to end users and what a researcher can do so that the software is archived, is referenced, or can be referenced, is described, and at the end, this researcher can have credit and acknowledgement. Now, another piece of guideline that we have surveyed in the state of the art is the guideline for software archival by Software Heritage, where there are 3 steps: preparing the public repository, saving the code easily with the Save Code Now, and referencing it in different articles. I'm not going to share all the guidelines that we reviewed because it will be a very, very long webinar. There is the link to the Zotero library if you are interested in finding out more which guidelines we have surveyed, and you can always drop a line to share guidelines that you want us to note if we haven't yet. Now, the CodeMeta initiative, for those of you who do not know, started in 2016 with the software citation principles. The first version of the CodeMeta vocabulary was released in 2017. It is a subset of schema.org, and around CodeMeta, there's an academic community discussing software metadata, exactly what I really love. And so the important piece that CodeMeta is bringing is a Rosetta Stone, translating different vocabularies in this metadata landscape into CodeMeta. Software Heritage is using CodeMeta to index and translate metadata that is found in the code. And so you should, if you are interested in metadata, you should get to know CodeMeta, the CodeMeta vocabulary, because it's really useful for metadata collection and capture in intrinsic files. So now we're coming to the point where I'm going to ask of you to work, to do. We have identified 7 aspects. Well, the first one is not really an aspect because it's a general metadata requirement, but let's say it's 7 aspects for this proposal. If you see on the right side of the slide, well, when you look at the right side of the slide, you'll see the crosswalk between these aspects and the SIRS report and the FAIR for Research Software principles. We will focus these aspects during the webinar, but also in the proposal. We have accessibility and, well, first, the general metadata requirements, then accessibility and preservation. The third one is reference and identification. The fourth, description and classification. The fifth, attribution and credit. The sixth, reuse, licensing, and legal aspect. When the word reuse is about the reusability of the piece of software, of the piece of code, and not using it, it's reusing it. And the seventh aspect, it is about reusing it because you need to execute. So re-executing the code with dependencies and execution environment. Now, for the activity, before I'm going to discuss the activity, just letting you know that in the document, it is divided into a high-level objective, each one of these aspects. Here you see the description and classification aspect, and a table with an ID of each recommendation and the text and the priority level. I'm not sharing with you the priority level in the live notes because we want your opinion, if it is relevant or not, to see how much, if we should put it as a high priority or not. And so for the activity, I'm going to ask you first to go to the link. Lost my screen. Okay, I got my screen back. Did you lose me? I don't know if you lost me. I hope I'm still here. And so you go to the document and you will have a set of tables for each one of the aspects. I need you to read the objective, which is copied in the document, and each recommendation is also copied to see if each recommendation is clear, if you understand the recommendation, and you can really just comment it. I don't understand that. And add in the relevant column, you can add the icon, the like icon or the dislike icon, or you can just write +1, -1. Really depends on you. +1, -1 will take less time. And so let's jump into the first objective, and I'm going to read it. I'm going to give you a minute or 2 or 3 or 5. I will see how much time my timer will let me have, and I will share a few contextual information after each one of these aspects. So first, the general metadata requirements. To ensure the collection, curation, and maintenance of research software metadata, the following general requirements are recommended for end users, including researchers, software engineers, curator, and institution staff. Now, is this objective recommended? With this objective or recommendation clear? Is it relevant? This is your time to think about it. I will give a few. Let's do 2 minutes. 2 minutes to think about it. It's hard to think when I'm talking. And I'm happy. I see that some activity is in this document. So I'm not going to read each one of the recommendations. I'm going to leave you free space. Feel free also to comment the text itself, and if you feel very inspired, you can also, while suggest modification of the text if you feel that you have a possibility to improve the text. Okay, I gave the 2 minutes, and I'm moving to some contextual information. So for the comment, I see that in the comments that we need to define inferencing and extrinsic, and I agree. It is in the state of the art, but it's not directly in the proposal. So to give you a few elements on that, here is a few different places where you can find extrinsic metadata, which is available on catalogs and registries. Here are some examples: ASCL, SWMath, etc. You can find also extrinsic metadata on scholarly repositories. When you deposit software, it is the metadata record will have the extrinsic metadata. You can find it also on the development platform. For example, on GitHub, you have on the right metadata that's inserted on the interface, which is not in the software. And you have package manager platforms also with some extrinsic metadata, even though most of the metadata is automatically used from the code. And finally, the scholarly publishers, where you submit an article and software, you will find metadata on the software or the research output page, which includes software. And so the intrinsic metadata is metadata that you find in the code. I've inserted here the view of software on software heritage. It's the Power Map software by Roberto Di Cosmo. You can find inside this directory, which I didn't. I wasn't a good student. I didn't put the reference, but I will do it later. You can see different files. It can include README and license and authors files, which are human readable, but not machine actionable. And you can have CodeMeta.json files, package management files, which are machine actionable. And so you have different types of files that you can use inside the code where the metadata is captured with the software. And this is good for metadata collection and archival. And later on, if infrastructures are aligned with this objective, they can, like the HAL French National Archive, they can use this intrinsic metadata and put it in the metadata record as a machine, while using a machine actionable file. Now, another recommendation in the general metadata requirements is the usage of a version control system. I'm not going to talk a lot about this because we won't have time to cover all the aspects, but the recommendation is to use a version control system. It can be local and it can be publicly available on the platform. And there are a lot of reasons why it's important also for the metadata, because you keep the development history. And when using software heritage for archival, you do archive all the development history. And so moving to the second aspect, which is accessibility and preservation. Now, the objective is to ensure accessibility and preservation. Researchers and software engineers are strongly recommended to follow the archival and sharing recommendations below. Now, feel free also to comment the objective itself. Is it clear? Is it relevant? Should we write more? I'm going to give you 2 minutes on this aspect without me talking. Just a side note, I'm very happy. I see a lot of comments and nice icons on the document. Thank you, everyone, for contributing. Okay, I'm going to move to my next slide, even if we are staying in this aspect with this diagram, which does not have a title, but it is showing some actions the researchers can do to share the software and make the software accessible. The researcher can develop on the Forge with public available software. Then it is shared and it's accessible, and there will be a code repository, but it will not be archived. So the easy thing to do is to submit a request to save code now, which is very direct. And it can be for any code. It can be for the researcher's code, and it can be for all the dependencies this researchers is using for the software, because you can save any code in software heritage, like the Wayback Machine for archiving web pages. Next, this researcher can submit a SWHID or a deposit, because here it's not seen, into a scholarly repository or another infrastructure. So this is kind of a diagram showing different types of infrastructure without really specifying. And there can be a review process. So if it, for example, a publisher infrastructure, a reviewer will check the software and the metadata. If it's a scholarly repository, it depends on the scholarly repository policies. And finally, this researcher can cite the software record, but this is not this aspect. The aspect that we're looking at now is accessible and preservation. And so as I said, you can save any code now with the Save Code Now feature. And I'm moving very fast to the next aspect, which is reference and identification, to ensure that research software projects, modules, versions, and source code artifacts can be precisely identified and referenced. And it is important to note, it's not written in the objective, that there are different granularity levels, and we need to make it possible to identify different levels of granularity. And so, again, I'm going to give you 2 minutes on this aspect before moving on. You're very busy. I see a lot of work on the reference and identification section, and I'm very happy to see that. Feel also free to comment other comments. So if there's a comment, you can write another comment below it, or you can add a Google Doc comment on the side.
Moran, while
Yes.
we wait, there was a question in the chat. I don't know if you noticed that.
No, I didn't.
Yes.
Can you
From
read it?
and for you? Yes, in the tables, there is no information on how to check if these criteria are met. Is it relevant to define a criteria if we do not know how to verify it? It was from Hannah for you.
This is a good comment, a good question. I will put it in the document itself. There's a Q&A section. You should know. I didn't mention that. Thank you, Sarah, for bringing that up. There is a Q&A section. We might, if we have time, I promise to go over the Q&A at the end of the session. And if we don't have time, I will answer the questions on the document, and you will have access to it afterwards. Here, the guidelines is more about trying to guide on a high level and not being too specific, using this specific file or not. For example, there is you will see later the usage of the README file, but this is conventional, but you don't have to do it. And so there wasn't an objective to place criterias. You should know that there is another deliverable coming from Fair Impact in September about the metrics to get fair software. So that might be a better location to do so. But let's give this, let's continue and see how we can answer this question better, maybe more specificity in the table, in the proposal itself. You should know that in the full document that you will see it, you will be able to read at the end of the webinar. There is a state-of-the-art section explaining a little bit from where we got all these recommendations. So I'm going to move on to the next contextual slides. First, to explain what is the granularity level. In this pyramid, you see the GL with a number, which shows a granularity level from the bottom to the top, where the top is the higher level identification, where you identify a full project. It can be, for example, Python, where you have project version like Python 2 or Python or another project version. You have modules, submodules, which are also at a project or a higher level, as you can see in this green, which is lighter, and where we will use extrinsic identifiers to metadata records that are not the software itself, and it can also note proprietary software. You can identify proprietary software. Then you have intrinsic identifiers, which are for lower level granularity level. When I say lower, where you have many of these, many snapshots, many releases, more releases, and then code fragments, you can have millions of code fragments in a project, depends on the size of the project. And this is a little bit about the granularity level. In the software source code identification output, it's an RDA output where you find the DOI here, released in 2020. There was this table, the granularity level summary, showing a little bit what can be used for each granularity level. Now, it's just a piece of information to have the context of what granularity level we can provide for each software. An example is using two identifiers, here a DOI and a SWHID, for IPOL articles. IPOL is the Journal of Image Processing Online, and they publish articles with software, because it's mostly the software that's the publication, but there's an article as well. The article gets a DOI, and you get with the DOI two metadata record with different metadata properties, and you also have a SWHID to the specific source code artifact that is archived in software. That's an example of using two identifiers and providing the possibility to reference the exact piece of code, a specific version that was used for this article, and also have a high-level extrinsic identifier for the article and the research output, because it's not only the article, it's the full research output. You have also something very high level, which is the Wikidata entities. If you know the QIDs for an entity, it's an extrinsic identifier, which can have inside collection of other identifiers, DOIs or SWHIDs or any other types of identifiers of specific version or specific other metadata records. And on this Wikidata metadata records, you can also add properties to describe the software, but it's a very high level metadata record for projects. I've mentioned the SWHID, but I didn't describe the SWHID. Maybe I should have put this slide before the DOI and SWHID slide. But the SWHID is the software heritage identifier. It's an intrinsic identifier. And it is calculated from the code like a fingerprint. So it's intimately bound to the designated objects. It can identify a file, a code fragment, even a code fragment in the code, directory, a release, a snapshot. So as you saw on the full pyramid of granularity levels, it has different level of granularities, but it doesn't go higher up to identify the project. And you have a blog post describing the differences between intrinsic and extrinsic, where intrinsic is really calculated from the object. It can be calculated everywhere. You don't need software heritage to calculate this object. And this is why also the SWHID is going towards changing its name to a software hash ID, because it is a hash. But for now, we are still mentioning it as a software heritage ID. Next aspect, and then I will give you a minute because we have still a long way to go to the end of these aspects. So this aspect is description and classification to ensure software findability and comprehensibility provide descriptive metadata, which can include software's name, purpose, functionalities, programming language, domain, etc. These metadata facilitate accurate representation of the software and enable users to easily discover and understand its capabilities. 2 minutes to go and a bit of silence. Feel free to put also questions in the recommendations and not just in the Q&A or in the Q&A. We will review all your comments after the webinar, I promise. It's very nice to see everyone on the document working so hard. I hope you have all access to the document and you're looking at each of the recommendations which are not listed on the slide. And I will move quickly to the explanatory slides. First, something that we can do is to add a good README. And what is a good README to a software? First, why a README? README is a form of human readable file to describe the software. It appears on the code repository as the kind of the landing page of the software. It is good practice, which is commonly used in industry, and now also I see it a lot in research software projects. Good README extracted from the Raymond Maker README documentation must include a name and a description, should include how to run and use the software, but we will come back to that in the execution, re-execute aspect, and can include some pointers, documentations, visuals, and news. And we have other properties that are listed in the recommendation directly. Here you can find CodeMeta properties that can be directly inserted in a machine actionable file. So you see that there are some that are not in CodeMeta, but most of the properties on this slide are in CodeMeta. In orange, I've circled the one that can apply to describe and classify. So you have different types of properties that you can use using CodeMeta.json vocabulary to describe the software and have it machine actionable. It can be indexed in software heritage and then findable. In the HAL French National Archive, the CodeMeta.json file is used to populate the form for the metadata record. So the information is not written by the researchers in the form. And we hope that infrastructure will go in that direction. And we're striving towards that. So researchers don't need to do metadata in the file and then in the record and in each one of the platform. It will be a very big hassle. And if there is this CodeMeta standard that is used and is accepted, it can be interoperable and used on many platforms. Next aspect is attribution and credit. To ensure proper crediting and acknowledgement of software creators, authors, and contributors, it is important to follow citation recommendation. And now we move to the other, to this aspect, and I'm going to give you 2 minutes again, because it's important to have some silence. And I see you have already been good students. Thank you very much for the feedback. I see that already this aspect is almost done with the commenting. Almost 2 minutes, and you still see people working, so. And go. Okay, so citation. Citation is very important to get recognition. And so I've used this image from the Turing Way project illustration about why it is important to cite software. It is important because this is the making it, well, I don't have the word like right now, but it is the reason why people use metadata and will provide better metadata and will provide better software, because the work that they have put in software is recognized. And so the citation principle, software citation principle, were published in 2016, also high-level principles that are very important to note, and they are listed in the state of the art. There was the CFF, the citation file format, that was created specifically for this use case of citation. It is a machine actionable metadata file that can be in the code. It has properties that are specifically for software citation. And there was in 2021 the GitHub and CFF integration, where when you have a citation.cff file in your repository, you can get a citation BibTeX export, or even just the citation reference in a.k.a. style. I think that was the possibilities. Now, moving on, even though I have a lot to say about citation, citation is really the hardest of the aspects, because you need to define who are the authors, who should be credited, how it should be credited. And for software projects, it's very difficult. But moving on to the next objective, because we have 11 minutes left, the next aspect is reuse, licensing, and legal aspects. To ensure proper software reuse and license compliance, it is essential to accurately describe software licensing and legal aspects. This includes providing clear guidance on proper usage and distribution rights, clarifying the terms and conditions under which the software can be used and shared. So this reuse is not about using the software, making it run, even though we need to have the right to run the software. So this is important too, but it's about reusing part of the software. And since we don't have a lot of time, I'm not going to give you 2 minutes of silence, and I will continue with this example with the reuse project, which is a guideline to how to choose a license and how to put this information in software. It's for open source software. And there is also the SPDX, which is software packages distribution. Oh, I have a blank. But SPDX is a standard that is accepted and in industry and very in use, and it should be also used by infrastructure to identify the correct license and how the license is put in the software. Next, we have the last aspect. Thank you. We got to the end of this exercise. The last aspect is re-execute. And this is not the French way of execute. It is the just rerun the software, dependencies and execution environment to ensure the usability of software and the ability to reproduce the same results in experiments. It is important that the software can be easily rebuilt and re-executed. This ensures that others can use the software effectively and achieve consistent outcomes. Again, you have the document, but I'm not going to, alas, give you silence, and I will continue to the conclusion. So maybe I will give you silence. Let's do a minute, because I don't have any context slide for this one, even though it is a very important slide, very important aspect to have in the RSMD guidelines, because metadata can do so much to make the software usable in terms of it can be re-executed. Okay, a minute, just a minute. And then we will go to the final part, which is the conclusion, Q&A. And for that, we have still 7 minutes, 6 minutes. Again, thank you for all your contribution on this document. Your feedback is valuable and important. And we need you to have the best guidelines we can produce. Okay, so moving on to the next steps. We are going to share the document, the full document, not just the live notes. And you can read it and review it if you would like until May 29th at 12 UTC. The live notes document will be open until May 25th at 12 UTC, because we need to get your comments into the main document, and we need to improve the main document with your feedback. And so this is why we are doing these two different deadlines for review. If you wish, again, no obligation. Now, the deliverable itself will not have you as listed as a contributor because it's a European Commission document, but we will have in the appendix the community that contributed to the effort. So you are going to be listed in the document as contributors if you wish to, as you have signed on the live notes participant list. So if you haven't yet signed your name, ORCID, and you want to appear in the appendix, please go ahead and take the time to do so now. We are going to share this tinyurl.com RSMD guidelines v1. I hope that someone can do that for me. Not sure if someone can, but if not, I will do it in a second when I stop sharing my screen into the chat. And another way you can contribute to the effort of metadata and research after metadata is contributing and participating in the CodeMeta community. The V3 of the vocabulary is expected at the end of the month, so very soon. We will do a dedicated webinar on CodeMeta in September, but it is a very live community where you can comment issues in the CodeMeta repository, and you can add issues if you have metadata concerns that you would wish to raise and have properties added or reviewed. Again, CodeMeta is a subset of schema.org, where we do have effort to get all the properties we are adding in CodeMeta to schema.org. So this is something we are working on as well. But we want to have a live community where there are discussions on metadata and metadata properties and how to do things the best way we can do. And so, just a second, let's see. Last, on your live notes, you will find a question after all the proposal, which is, how can we make the RSMD guidelines format of most value to you? Please, if you have the time to give us some feedback on how you will use the RSMD guidelines, what format will be the most useful for you. We do plan to do a checklist, which after the proposal is stable, so that this checklist can be directly taken by researchers and end users and curators, and kind of with checkboxes to verify that all the aspects are checked. So this is one thing that we are thinking of. If you have other ideas, maybe another webinar, this is something that we can do with the final proposal, showing how to do it, maybe how to guide. You might have very good ideas that can help us help you. And so thank you very much for participating in this effort, participating in this webinar. I was grateful for your for having such a wonderful crowd. I'm also thankful for the full task for producing the deliverable and the proposal, and especially to my colleague from Software Heritage, Sabrina, who has worked with me through the sprints that we had to make this deliverable what it is now. But all of the participants of the task have given their point of view. And with that, we are arriving to the end of this webinar. And so if you have any questions, you can keep in touch with me at moran@softwareheritage.org. You can also follow the Software Heritage news with the newsletter, but you can also follow the Fair Impact newsletter. I don't have the link here, but you can find it in the Fair Impact website or Twitter account. I hope you enjoy this webinar. There is a form to give your feedback on the webinar, and I'm not sure, but maybe Sarah will be sharing that. And again, I want to thank Sarah for being here with us behind the scenes and doing all the extra work from Trust IT to make this webinar possible and promoted, and have you all come here, because thanks to her and Rita from Trust IT, we got you all at this webinar. So I'm going to stop sharing my presentation, and thank you, everyone.